So this is really related to exponential growth, which is what we've been talking about. But this is a specific, this is a form of exponential growth that's a little bit different. Okay, it grows by a specific factor every time. And what I really want you to take note of is this word continuous. Okay, that's going to be the word that you'll be looking for in your problems to tell whether you use this method or the other method, the AB to the X. Okay, so the word continuous is very important. A couple of things to know about continuous growth or continuous decay. Okay, continuous growth is when exponential growth is happening constantly. Okay, and you saw that in that activity that you were doing as you compounded more and more often. All right, so where you were compounding, you went from yearly to twice a year to 4 times a year, all the way down to like 31 million times a year. Could we compound even faster than that?
Oh, yeah.
Okay, could we go every half second, something like that?
Sure,
we could, and that's what's considered continuous growth, okay? And it doesn't get like exponentially bigger. It actually sort of reaches this plateau, and that's the number that you saw, the 2.718, blah, blah, blah. Okay? So as you compound more often, and this was the whole goal of that activity, the more often you were compounding, the function gets closer and closer to this special irrational number. Okay? Which, by the way, if you're still frantically trying to fill in that table, please stop that right now. Okay? You should be just paying attention to notes. Okay? What you should have found at the end of that activity is that you came up with this number 2.718, but the decimal went on and on and on, right?
Yeah.
That is actually called E. There's a special name for that number. That number is called E. What does irrational mean? Didn't quite hear it. Anybody think they know mathematically what an irrational number is? D? Oh, okay.
It means it's not a whole number.
Okay, it's not a whole number.
It's not, is it
Too much of a decimal, too many decimals.
a negative?
Close. There's one other really famous irrational number. Kayla?
0.
What was the question?
Well, either tell me what is an irrational number or what is another example of an irrational number.
Pi?
Pi. Okay. What is crazy about pi?
It doesn't stop.
Doesn't stop. That's what irrational means. This number E, this 2.718 ... that ... means that decimal goes on and on and on forever. It's kind of like E's less famous cousin. Okay?
Wait, so if we put that in our calculator?
Yes, there is going to be a way we're going to do it in your calculator. In your calculator, it's just going to round it off, just like if you use pi.
Oh, I thought you
It
could, like,
puts
go-
quite a few decimal points in there, but it will still round off. Okay? Okay, so continuous growth, and again, there's that word again, continuous. This is the model of growth that is found more often in nature. If you were to measure the growth of a plant or population growth of insects or something along those lines, instead of being that exponential growth model that we looked at before, it's more similar to this model, okay, that uses this magic number E that shows up in all kinds of stuff, okay? And then I will be honest with you here. Continuous interest. There are a lot of math problems out there that ask you to calculate continuous interest, which make me think that it must be a real thing somewhere. But I have never seen a bank that offers continuous interest. Maybe I'm not going to the right bank. Okay? Maybe I'm not rich enough to be going to the right bank. Perhaps. So continuous interest is just another model of calculating like your interest and how often it's being compounded. But again, you're looking for that word continuous to know when to use this E. Okay, let's go ahead and write down this formula and then we'll talk about it. A equals PE to the power of RT. This is for compound interest. So this formula, A equals PE to the power of RT, technically that formula was written to represent compound interest, meaning like bank accounts. Okay? What do you think P represents?
Principal.
Principal, which is the same as what?
Beginning amount.
Okay, that's the amount you're investing, yep. And E, shh, guys, can you stop the chatter? Okay, E is that number that we just came up with. E is that 2.718 number. You don't have to worry about knowing that number. I'm going to show you how to do it in your calculator. What do you think R is? Rate, interest rate. In this case, it's interest rate because you're talking about compound interest. But in other scenarios where you're not talking about like bank accounts and whatnot, the R just stands for the rate of growth. Now, remember before when we did this and I told you that you were growing by 20%? What did you have to do with that 20%? You had to add it to 100 and then move the decimal, right? In these problems, because the R is up in the exponent, you do not have to add or subtract from 100. You can just put the decimal directly into the problem.
So what's the T?
Okay? What is the T? Great question. Okay. Now, everyone okay with all those pieces? Especially once I tell you that you can type that whole thing into your calculator.
No. Just one.
I'm about to show you one that looks scarier.
Just in one shot.
I want you to know that it's exactly the same as this one. Okay? And I will show you as soon as you stop talking. Okay. So take a look at this formula down here. Let me move it up so you can see it.
Yay, letters.
For any function that grows continuously, n of t is equal to n sub 0 e to the power of rt. Okay.
What do you mean by sub-zero?
Sub-zero is that little zero that's written down on the bottom underneath the n.
I know that.
Okay, like what does that represent? We'll talk about that in just a second. Let's make sure we write it down. Okay, what does, we talked about this in one of the problems we went over yesterday. Dee, please pick that up. Okay, we talked about this in one of the problems we went over yesterday. When I put that little zero down there, what does that tell you about that value?
It's 1.
No.
Almost. You're thinking along the right lines.
Exponent is 0.
Okay, so focus and listen to me. Okay, do you see that this function is really very similar to this function? Like, look at this. ERT, ERT. The only difference is this one has a P and this one has this N sub 0. Now knowing that, somebody raise your hand and tell me what you think N sub 0 represents.
Oh, it means... Oh, 0 would be your starting value.
Okay, it's not that 0 is your starting value,
This is where you
but
start.
this is your starting value,
Yeah.
or your initial value. Okay?
It's not.
What letter did we use before for our... When we did exponential growth before, when we did AB to the x, what letter did we use for our starting value?
E. I mean A.
A. Okay. I could very easily rewrite this scary formula as y equals AE to the power of RT. All I did was use an A instead of this scary N sub 0 thing.
So what?
Okay.
Oh, the N goes with the 0.
Right. The N0 is all one thing. Okay, so it just represents your initial value. Now here's the thing. This formula up here, this PERT formula, is designed specifically for compound interest. So they use a P for principal. All right. Any other thing that's growing continuously, you should use either this or this. But really, aren't they all the same formula? Do you agree that they're really all saying the same thing? It's starting value times E to the power of rate times time. So I have a lot of students who just remember this formula because PERT seems to be an easy thing to remember. So I don't care if you always call it the PERT formula. Just know that P is really meant to stand for principal, and you can just kind of treat it as whatever your starting value is. Okay? So let's try an example. $850 is invested at an interest rate of 6% compounded continuously. Please underline that word for me, continuously. Continuously, that's the word, and that word specifically is the word that you look for to tell whether you should be using the E formula or the stuff we did before. It must say continuously. It's not going to say like all the time or constantly or anything that sort of means the same thing as continuously. It's going to say exactly the word continuously. or continuous. All right? So when you see that word, it should trigger in your mind, hey, I should be using an E formula here. Okay? Isaac, question?
I have a formula.
Okay, so the fourth here.
Wait.
Okay. Oh, Jotea, go ahead.
So what's the difference between the two?
The AERT and the PERT?
Yeah.
There really is none. The PERT formula is written so that this P can stand for principal. All right? Whereas the other one, the A value, just stands for whatever your starting value is. But if you just always want to use this one and say P is your starting value, that's fine. Okay?
So you can choose either one
Yeah.
at all times?
Yeah, because they're just using different letters for that starting value.
Okay.
Okay, so as long as you know that first letter is your starting value, I don't care which formula you're using because they're really all the same thing.
Okay.
Hunter?
There are a test, like if you don't have to like write down like what you want to use.
No. No. Yeah, and I'm fine with it, whatever you use. Yeah. So don't stress about the different formulas. My point to you is that they're really not different formulas. Okay, they're all the same thing. This one I'm using PERT just because it's interest. It's talking about interest rates. So what is my principal here? It's 850. Time, we're going to talk about this in your calculator in a second. Power of, what's my rate? Okay, it's 6%, so it would be 0.06. Sean, question or you just have the answer?
Never mind.
Okay. So 0.06 for my rate. What's my time?
10
years. And in your calculator, you may have to, well, I'm getting ahead of myself a little bit, but this 0.06 times 10 might need to be in parentheses. Here's what you're going to do. Type in 850. And then this E button, somewhere on your calculator, you should have a button that says E to the X.
Yep.
Okay? It's probably above another key. Okay, above the LN key. Yep. Okay, so if you look over on the left side, probably if you have an LN key, it's going to be above that. So you're going to hit 850, and then hit second and whatever button you need to get E to the X. And what will happen is E will come up and then automatically give you a spot for an exponent. And then you, possibly in parentheses, depending on your calculator, type in 0.06 times 10. Okay? D, question or you have the answer? Okay, let's give everyone a chance to type. What did we get?
1.8.
1,048.800.
I'm sorry, D, I already put it up on the screen. I'm sorry. You're right, I should have called on you. $1,548.80. Who did not get that?
I got it.
Okay. Okay, let's try one more example. A machine used in industry depreciates, so we're going up or down? Down. Depreciates continuously, there's that magic word again, at a rate of 25% per year. Currently, the machine is worth $28,000. So the first question says write a model, which means write an equation for just t years. So we're going to leave our time as t. So here's where I'm technically using this formula. But remember, this n sub 0 really means the same thing as that p did before. So I don't care how you think of it. Okay? So what's our initial value here? 28,000. And then I'm going to go. Now for these ones, remember how I said you don't have to add or subtract from 100 to get your R value?
No.
You just make it positive or negative. So is this going to be positive 25% or negative 25%? Okay, so I'm going to say negative 0.25 times, that's my equation. So if a company is making an investment in this machine, this is something that maybe the company that's selling it to them, or maybe like a business analyst or something, would provide to them so they can see how much it'll be worth over time. Okay, Kayla?
Why is it negative?
Because it's depreciating. All right? So it's going down. And so with this formula, that's how you deal with going up or going down. You don't add or subtract from 100. You just make it positive or negative. Okay? So how much is it worth in 3 years? Jotea, you have an answer?
Yeah.
Okay, hold on. Let me put it up. Look like. So what I would do to type that in, and actually probably I should have the parentheses around these two together. Okay, that's how we're going to type it in. Let's give everyone a second to type. Jotea, what'd you get?
I got 13,226.3. Do we round
Okay.
or not?
This is money, so I would round to 2 decimal places, so I did 0.26.
Right.
Okay. If you had said 0.3, I wouldn't have marked you down for
I
that.
got something times
So,
10 to the
$13,226.26. Colvin, you didn't get it again?
I got something times 10.
Okay. All right, next question. How much was the machine worth 2 years ago? Okay. What am I going to do with this one? How do I make it go 2 years ago, Hunter?
You're gonna do -0.25 times 2.
Okay. But do I want to put in a positive 2?
No.
Zach, what do I want to do? Okay, because I'm doing 2 years ago. I'm doing 2 years in the past. Want to go backwards? So I want my t value to be -2. Would you expect this number to be bigger or smaller than 28,000? Bigger, because the value is going down, right? So if you go back in time, the value should be higher. Whoops. Here it is down there. Okay, -0.25 times -2. Isaac, what'd you get as an answer?
$46,054.20.
That's it. Okay. You did not get that? Okay.
No.
You're good? Okay. Questions, problems, concerns. What magic word are you looking for? Continuously. Okay? Then you go back to that old way we were doing it with AB to the power of X.
Is that going to be happening?
I'm not sure. I don't think on your homework tonight, but on your quiz on Thursday it'll be mixed up. You'll have to figure it out. Okay? Okay.